Principal is 100. Amount at the rate after first year is 110. Amount at the end of second year is 121. Amount at the end of 3 years is 133.1. 133.1. How you got? It is 10% of 100 is 10 more. 10 more. It is 10 rupees more. 110 of 121. 10% of 110. 10% of 110 is 11 more. 11 more. Are you all with me? Now, again 10% of 121. 10% of 121 is 12.1 more. Listen carefully, sir. Here it is 10 more. Here it is 11 more. Here it is 12.1 more. Can I write it as 10 into 1.1? It is into 1.1. Here also it is into 1.1. 11 square is 121. 11 into 1.1 is 12.1. That means, can I tell 110 into 1.1 is 121? 121 into 1.1 is 133.1. 100 into 1.1 is, what is this 1.1? On 100 there is a 10% in increase. What is this 1.1? On 110 there is a 10% increase. Are you all with me? What is this 1.1? On 121 there is 10% increase. Very, very important point. This is after first year. Here it is 1.1. Again after 1 year, 1.1. Again after 1 year, 1.1. Into 1.1, into 1.1, into 1.1. If the ratio between two values, it is the same. 1, 2, 4, 8, 16. Here it is into 2. 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 That means if the ratio between two quantities is constant, then the series is said to be in geometric progression. Extremely important point. Very, very important point. In compound interest related problems, P, A1, A2, A3 and so on up to AN, they are in geometric progression. They are in geometric progression. What is the ratio we got? What is R value? 1.1 we got. Then what is R value? R is given by 1 plus R percentage. In algebra it is common ratio, right? Here it is 1 plus R percentage. This we call it as scaling factor. Scaling factor is the common ratio in algebra for compound interest related problems. Very, very important point. If time period is the same, scaling factor will also be same. Please look at the question, sir. Scaling factor will also be same. If time period is the same, scaling factor will also be same. Time period is the same, scaling factor. For first year, 1 year, 1.1. Again 1 year, 1.1. Again 1 year, 1.1. You can draw a lot of conclusions based on this. P, A1, A2, A3. 1, 2, 4, 8, 16 and so on. They are in GP. First term, third term, fifth term. Are they in GP? Yes. 1, 4, 16 and so on. P, if whatever the time period gap is there, that value will be in geometric progression. P to A2, 2 years gap. A2 to A4, 2 years gap. P, A2, A4. If I take 3 years gap, again 3 years gap will be there. Time period gap, if it is same, scaling factor will also be same. In some textbook, we call these factor as multiplication factor. Sir, why it is multiplication factor? Just look at it. 110 is multiplied by 1.1 to get 121. 121 is multiplied by 1.1 to get 133.1. Simple interest. Simple interest, if you observe, the deviation is plus, 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 plus. It is an addition factor. What is that addition factor? Addition factor is the change on interest. SI behaves like arithmetic progression. CI behaves like geometric progression. Geometric progression. Now, if you observe P, A1, A2, A3 and so on up to AN are in geometric progression. P, A1, A2, A3 and so on are in geometric progression. Geometric progression. Geometric progression. Geometric progression. If the time period gap is same, then it is the multiplication factor will also be same. Multiplication factor will also be same. Multiplication factor will also be same. Another important observation. Listen carefully here, sir. Another important observation. What is these interest value? 10. What is these interest value? 11. What is these interest value? 12.1. Interest values 10 into 1.1 is 11. 11 into 1.1 is 12.1. In fact, 10, 11, 121. The interest values per year, they are also in geometric progression. Please write down. The interest values per year. The interest values per year, they are also in geometric progression.